Hey everyone, welcome to another episode of the Common Lisp Study Group. I'm your host, Ron Badum with Atlanta Functional Programming. My apologies for the late start tonight. Unfortunately, let's just say traffic kind of screwed me at our timing and other logistics. Anyway, I did not want to delay it any further. So without further ado, today we are going to be continuing our discussion on paradigms of artificial intelligence programming, case studies, and common lists, specifically on the section on um, profiling. Now, I wanted to mention this ahead of time for folks who might remember that I mentioned indexing as being part of the discussion today. I realized when I was reading um, the book the other day that indexing also is mentioned in section 9.6. And I want us to kind of go through some of the profiling stuff a little bit more in detail, mainly because it's kind of an approach with instrumentation in general that I should have thought about it, but I didn't think about that this being a capability in Common Lisp until I was introduced to the associative list and the symbol function just, in the book itself. So I thought we would do some deep dives into um, looking into that first and then have a much more deeper discussion on indexing later on, depending upon, either the time, maybe not necessarily today, but certainly next week. For those of you who like our content here on the Common List Study Group, please hit the like and subscribe button on YouTube. And for new video notifications, please subscribe to our channel, Atlanta Functional Programming. Just to let most of you know in the Atlanta area, Atlanta Functional Programming is looking for speakers. If you have a topic, I do reside in the Functional Programming Slack channel most of the time, as well as Tech 404, which is the Atlanta Tech GitHub, Slack workspace. So, for those of you who are on the Tech 404 Slack workspace or Functional Programming Slack on Lisp, feel free to DM me with your talk topic, and I will, get it scheduled. For those of you who are on the Lisp Discord server, I'm also there too. My alias is the same across all the platforms. It's just Bugram. Go ahead and reach out to me and get your topics in so that we can have some nice, interesting discussions on either Common Lisp, Haskell, or any functional programming topic that you want to talk about. So last time we were talking about delayed computations. I kind of mentioned the kind of to introduce this topic that we we're going to be talking about, indexing and instrumentation. The first things is instrumentation. To begin with, most of you are probably aware that in Common Lisp, and let me just go ahead and fire up our, nice little uh, SLI interpreter. Common Lisp already provides some instrumentation for us, okay? It's actually part of the standard, okay? You may have seen me on more than one occasion, maybe using trace, for example, um, to actually go and trace through a particular stack, all right? And it evaluates, particular context. There's also, if you are so interested too, and this is something that we're going to be talking about. There is the profile function too as well, which will give you a nice, you know, um, uh, section of a detail of profile function invocations, and especially if you have very complex code, it'll actually go and tell you what function is called and for how long. We're going to be touching base on profile in the first part of today's discussion, but on top of that, I just thought I'd mention trace just because of the fact that um, the book kind of pointed out that trace would be a useful topic to like go through. One second here, just getting my notes fired up here. Um, So, right. Um, but up until now, we haven't actually, I haven't actually really given and provided this kind of motivation about, some of these instrumentation utilities that I'm mentioning here. Most of you coming from other languages are probably well aware that being able to improve the efficiency of an implementation is a very good idea, but you need to also know what parts of a particular implementation need to be optimized, right? To quote Donald Knuth, who is always, you know, this is one of the most quoted, often quoted quotes of his, premature optimization is the root of all evil. You need to be able to figure out a way what your bottlenecks are and be able to obviously optimize only those bottlenecks so that way you could get the biggest bang for your buck rather than trying to optimizing everything and not necessarily getting, you know, not concentrating on what is necessarily needing to be optimized up front. And obviously knowing what would give you minimal gains if you end up optimizing anyway. All right. The basic idea about the first thing that we're going to be touching base on is the fact that um, while profile is there, um, historically, a lot of Lisp systems may or may not have had that functionality, and to the extent that you would like to see. So what Dr. Norvig did is he went ahead and wrote a pretty decent profiler, very simple, minimalistically actually, in Common Lisp. Both has a function. We're going to see the function implementation here for a minute, and then he would mention that obviously, it would be a good idea to macroize this, and we'll touch base on that too. Um, So let's go and look at the function idea. All right. So let me go ahead and create a scratch buffer. Um, okay. I'm going to go ahead and go ahead and open up Roswell, our local projects, and let me fire up PAIP exercises source main.lisp. I think this one is punctuation. Oh, this is our ELIZA implementation. Right, right, right. Let me go ahead and add a new one to our ASD file for today's discussion, just so that we separate, the different implementations. Um, for folks who are wondering, at some point I will check this all into GitHub. Right now, I didn't. I will add it to GitHub after our discussion today. So if you guys are interested in looking at what we have afterwards, feel free to stay tuned. I will post the GitHub link as part of the YouTube description once I have it checked in. Okay, so let's go ahead and create in source profile.lisp. And before I get started, let me go ahead and load PAIP exercises. Okay. What? I thought I checked it. Hold on 1 second. Okay. Okay. So we now have that all in. Let's go ahead and I should have actually did this first, which is create the package that we're going to need. Okay. UIOP define package. We're going to call this guy PIP exercises dot instrumentation. Okay. And use not user use CL. Okay. let's go ahead and load this guy. And also, let's add ourselves in PAIP exercises.implementation too as well. Okay. Okay, so we're now in the instrumentation package. Okay. So in here, we're going to go ahead and create our own my uh, uh,
Hey Rom, can you make the font bigger? It's
oh shoot.
literally
My
unreadable for me.
apologies. Here we go. How's that?
Okay, cool.
We good?
Thanks. Better.
All
Yeah,
right.
thanks.
No problem.
Yep.
Uh, just wanted to make sure. All right. So the book naturally calls this, and this is something that most people are aware. Um, uh, Profile one actually is what it uses. It's not profile. My apologies. Um, and that's what we're going to call it too as well. And the reason is um, there's already a profile inside of Common Lisp, and it's already interned. So if you end up creating another profile, you you will have a named conflict here because that profile for symbol is in um, the CL namespace, okay, or the CL package. And since we're using CL in our um, package, we cannot actually use profile as a symbol, intern symbol within our package, unless we somehow unintern that profile, and that could cause some problems later on. In fact, I think it's disallowed. There are some symbols that are reserved symbols that the implementations prevent you from making some changes. At least the book was mentioning this. That anyway. Um, so let me go ahead and say, what does this function do? Well, this function takes a function name, okay, and all this is doing is remember that the function name is just a symbol, right? But we need the symbol object first to go in and construct the profiling information. Because what we're going to do is given that symbol object, and that's the symbol function object is what I should be more specific on. We're going to attach metadata to this. Now, this is kind of, again, the beauty of Common Lisp. And I think this inspired Meta, if I'm not mistaken. The metadata, I think it's the caret symbol enclosure. Um, there's an associative map on every symbol function that we can attach to um, information, well, tags and information that we can use later on to provide additional instrumentation without actually modifying the code necessarily. And in this case, what we're doing is we're leveraging that to actually create essentially a counter to see how many times a particular function gets called. So let's see how this works. So we need to first create we need to grab the function. That's going to be just symbol function name. Okay. Now what we have is the function object. Okay. And we need to actually provide some, some information regarding the profiled well, some profile information, and then we can actually go in and make some changes into um, the what's that? We need to make some changes into specifically uh, what the function is when it gets called. Okay, so we're gonna do this using the generalized setf expander. All right. Now you could do this. The book actually does this in separate setfs, but since this is a generalized expander, I thought I'd show you again to review for folks who may not have seen this. This is a generalized, this allows you to do multiple assignments in a single setf. So it basically is going to be, think of this like x equals blah, y equals blah, z equals blah, the way I'm going to write this, okay? And it's in a single setf. So in the first one that we see, we got the function name. Um, um, 1 second. Need to mute my phone here. Keep on. All right. So the first thing is we're gonna uh, first create the unprofiled function. Okay, we want this just later on when we are um, uh, um, when we want to call this function and if we want to actually return the the unprofiled function when we go in profile, and you'll see this in just a minute. Okay. Um, the next thing we want to do is we want so when we're done profiling, we can actually go and just return the original function pointer back. Um, all right. So the next thing we need to do is we need to in here create a profile count. Now notice each time this get symbol indicator, I'm just going to show this again. Just give me a second here. Okay, this get symbol indicator is basically the think of it as the insertion point when you do the set f in uh, the symbol function object to keep track of this information. And I'll show you this when we first create the a profile for something, um, how this looks like in the inspector. Okay, so we have now the unprofiled function. So when we want to unprofile, we have the profile count too as well. We want to also keep track of the profiled. We need to now actually create the profiled function. Okay, and what this profiled function will do is every time you invoke the function, it will actually update the metadata profile count. Okay, and this is just a simply reassigning symbol function name with a call to profile function, and we'll define this in a minute as to what this is going to involve. Um, and we're going to call this function and the function name. Okay, hold on. This is function name and function. Okay, so that's it. We have what we need. And let's go ahead and return the function name. This is kind of what uh, Norvig did to see if something is successful. Okay, so this is our first thing. Okay, 1 second. Why is this not? Okay, so this is good. All right, so let's define what profiled function is first. Okay, give me a second here. There we go. This is going to take again the profile function name. Okay, and function. And what this is going to do is it's going to return essentially uh, a lambda. Okay, it's actually a closure to be more exact. That basically takes in. Remember now, lambdas are basically generic functions that essentially has the same lambda list as your typical defun. Um, so it's going to take all the args here that's going to be passed into the function, and what it's going to do is before it does anything, it's first going to increment the counter, all right, when it gets called. Okay, so incf, and the place that it's going to get is basically the profile count from the function name. This is kind of why you needed the function name itself, because we're using that as the lookup. And then what we do is we just simply call apply, okay, on the arguments, and that's it. Okay, so now we have our profile function, we have our profile. Before we actually test this all out, the other one that you want to have is naturally unprofile. And what unprofile does is, has the name indicates, once you have function name, what this is going to do is it's going to do the opposite of what we had before, which is it's going to set f the, oops, sorry, my apologies, set f the symbol function of the function name, okay, and it's going to set that back with what we previously cached and the unprofiled function metadata earlier, the function pointer that we labeled as unprofiled function, okay? And once we do that, we just go ahead and return the function name like we did earlier, okay? So to review, what we do when we profile, in this case, in the simplest case, we keep track of the function pointer in unprofiled function so that we can return it when we want to unprofile, stop profiling. We provide a profile counter, again, has a piece of metadata to the function name. And then we create a profiled object that really is nothing more than a closure that increments the metadata profile count and then applies the function to the arguments, right? So let's see how this works in our section. Okay. By the way, oh, there's two other functions that I should actually provide, which is this here needs two more functions. One is naturally the way to access the profile count, right? So we provide the profile count using the function name, and all this is doing is just, hold on one second. Why is this? There we go. And what this is doing is just accessing the metadata on the function name. And it's important to keep track, a note that there won't be any name conflicts in this design if folks are thinking there might be in the way this works. And the reason for this is it goes back to the beauty of the symbol object, right? Even though Lisp, Common Lisp is Lisp 2, um, symbol functions can have to have unique names, and symbol values have to have unique names. But the same symbol can be used for a value and a function. All right. Um, that's where the confusion ends up coming in. So if you're just talking about functions, everything is unique. If you're just talking about values, everything's unique. But when you talk about them together, that's where everything breaks down. All right. So, and I think I've provided an example of this in the past, but the classic example is you label, a symbol function named square, and then you have a variable named square, and you square square, or you have something called x, and that's a function and a value too as well. So f of f, for example. For a function f and a value f. If you can write really crappy code can be written in any languages, but Common Lisp does not escape the crappy code and bad habits that some people may have. All right. Um, the other thing that we might want is for a list of functions. All right. Um, or function names. what we could do is we could create a report for every function in the function name, so that way you can actually look at the functionality that was provided to you that you so nicely went ahead and profiled. And the way to do that is just simply do define in his framework profile report. Okay, it takes a list of function names and an optional key that will default to the profile count. And all this is doing is loop for, I'm sorry, I should use for name in sort, oops, not int, in sort function names based on key. Predicate is going to be greater than, okay, based on key. And this is going to give you, the largest number of counts for each function name. So this is in sorted order, naturally. Do we're going to use format here. Okay, format t, and our format string is going to be a little bit. So we're okay. I got to remember the tilde 7D is basically spacing it to 7 digits. The ampersand in the format is for, oh crap, this is I am having a brain fart right now. The ampersand for the, okay, hold on. I gotta go look up the format operators again, because I always end up having these format like brain farts for it, because rarely I use I don't do like tabularized format that often, but it has its obviously it has its uses when you need them. It is, if I remember correctly, it's going to be in pretty printer options, right? Not this one. It is, that's conditional new line. If you do underscore layout control, no, not layout control. It was in the printer operations. No, not that. It was, so tilde 7D is basically rounding it to putting it in decimal places, but maximizing it to, I think, 7 decimal places. Um, Here we go. Fresh line. So this is a fresh line, and then it's going to provide the information related to uh, the actual profile count. Okay, and so we do uh, space. Yeah. Oh, my apologies. I forgot the tilde. Fresh line tilde a. Okay, and this is going to hold. Um, oh, wait a second. Do I need to? Looks like this is quote A. Oh, no, my apologies, not quote. It's single quote like this. I'm wondering what this is. This is a new one to me. I've seen this. This is the one thing that about the book that I wasn't sure about that I wanted to try out here. Name and name. Okay. Let's see if it hates too many arguments. Okay. That's what I thought. I have to actually provide tilde like that. There we go. Okay, that's a formatting error in the book that I wrote down. So my apologies. Okay, so let's try very quickly a very simple function. Let's just make defun test sum up to some max count. Okay, and what we'll do is we will loop for I up to max count from 0 up to max count, summing I. Okay, this is a pretty standard thing, just some long computation. I like reductions usually. So this is a linear time function, and just to see how this works, we could just show you test sum. Can type test sum 10 returns 55 or 100 will return whatever. So let's go ahead and write profile 1 test sum. Okay, and let's call test sum for 100,000. Okay, now when we call profile count function name, sorry, profile count test sum, you see that it's been called once, and if we call profile report on just test sum, okay, you'll see our report, which will just give you the number of calls. Now, naturally, this doesn't have any nested calls. I could show you that by creating a simple here top level thing called test sum 2 that calls test sum several times. Sorry, test sum 2 up to max count. Loop for I from 0 up to max count. Do, and we can just call test sum here. And by the way, before we actually use this, let's go ahead and unprofile and reprofile this guy. So this way we're starting from scratch. Okay. Profile 1, test sum. Okay, so now we're going to call profile 1, test sum, and we're going to also call profile 1 on test sum 2. Now let's call test sum 2 100 times. Okay. All right. So now we'll see if we call profile count on this, on test sum 2, that it's going to be just once. All right. But if we call the profile report, which will give us on test sum 2 and test sum, you can see that it sorted the two, and it will actually give us the number of times something is called. Um, so this is just kind of the basic idea on how. Actually, wait a second. Why is that 101? I thought I unprofiled this. Hold on a second. Okay, this should throw an error. No, it doesn't. Interesting. Interesting. So, okay. Okay, this is a mental note to self that unprofiled. Oh, did I forget to? No, I did create the um yeah, for some reason that. Okay, I need to figure out why that's the case. That should not for some the metadata for some whatever reason is not resetting itself. That looks weird. Um Even though I'm returning the correct um unprofiled member here. Um, you know what? I'm going to also do this just to be on the safe side if that's happening. Um, Before I do anything, do get function name profile count, reset that, and then do that. So now do this. Okay, unprofile. Perfect. Okay, so now this is guaranteed to always do that. So we now know that it's never, even though test sum is in the list, it doesn't have any information because we've reset it when we unprofiled it. Also, let's go ahead and unprofile one. Now, the one thing I'm going to point out here, and this is the same thing that the book kind of points out too, is the fact that these this bare bones functionality can be improved specifically if we end up leveraging the macro approach. Okay, the reason why the macro approach is useful is it allows uh, code generation to actually go in and profile multiple functions at once. And additionally, because we're generating that code to figure out um, the profiling like flow, we can also keep track of what has been profiled, which is useful when you're trying to figure out, for example, um, say additional things like uh, you could like time how long a particular function is getting called. You can also avoid with profiling macros potentially invoking the profiling function twice because again you generated the code to actually go and create the profiler. Um, so right now the way it's currently designed, you could potentially call it twice and um, uh, end up messing things up. Um, so just because of the closure. So the first time you call profile, I'll show it. My apologies. I'll show this just to give you an example. Um, if you call profile one on test sum here, and then call it again, if you think this second profile is going to use the original implementation of profile, you would be wrong. And the reason for this is remember what we did when we actually invoked profile. right? We actually changed the function definition on line 10, okay, right here to give you more things. And we changed it to the profile function. So effectively now, if we go look up the symbol function, okay, um, here for, my apologies, there's a sly inspect that I need to use. Um, it's actually, let me go. I think I have to go in here and do um would be help, and no, that's not it. Um, it is um e no, no, not e, not compile, nothing. Stickers. Let's see, trace. Top trace. No, no, that's not it. What was it? It was. There's a way to actually go and tell. Oh, is it this? No, it's asking. Go to. Go back previous sticker. Oh, this is sticker navigation. All right, no bother. I can actually do this in a different way. We do sly inspect, control CI, inspect the result. So symbol function test sum, and you can run it. So you can see here in um, the the function itself has changed to a profile function, right? Um, And it even tells you it closed over values of another profile function that if you go and look, ultimately is closed over the function object. So this is the problem with function invocations multiple times. Now there are probably ways to update the function call to do this, but if you're going to go through that much trouble, just writing the macro correctly the first time would be useful and to your benefit. Okay, does that make sense to folks? It's important to understand that this instrumentation piece, this metadata piece, helps you. Uh, while functions give you the ability to write this nice invocation, one of the beauties of the macros is that you could do this all up front through just simple code generation, and it'll look like a function call, and you have some better abilities to actually go in and extend it without having to write additional logic during the function, which will slow down execution, right? Because the function invocation is going to be slowed down through the fact that you have to write all this additional logic to maintain lookups where a macro would do something very different. All right. All right. Okay. Um, are there questions on this? Just because before I start showing you how one might end up writing, I mean, this is the second example that was in the book related to the profile macros themselves. I thought I'd at least, touch base on, you know, what or answer any other questions on how this might look up. Okay. Um, One thing I want to point out that uh, these macros, well, not so much the macros, the actual profiling information that was in this chapter that I thought was pretty nice, um, is the fact that what's it? You don't want to necessarily um, So originally in Common Lisp, this is more of a historical consequence. Common Lisp, the first edition, all right, so that's 1984, okay? 1990 is when the second edition came out. Um, it was originally the case that you can that when you're considering and this is the use case, let's say that you profile a function and then the so-called profiled function gets redefined, okay? The only way to ensure that the redefined function gets continued to get profiled is essentially updating, say the at the function definition time, the to look for functions that were and should be profiled, and then attach the profile information or profile macro to them, right? Now, one of the problems was is naturally most of you know defun macro um, was the one that would ultimately do this work, and changing defun because it's a system level function to do this kind of profiling or this kind of instrumentation use case is very risky for various reasons. You might end up over profiling, adding additional instrumentation to other things, changing the a core keyword effectively is itself bad practice, and so many other reasons, right? And so in the second edition, they disallowed you to being able to change a system function. Now, the reason I bring this up is if you go and look at older Lisp systems, okay, you might see some folks do these kinds of crazy things. And there are a couple of older Lisp systems out there still. One that I encourage everyone to look at, um, that's getting actually modernized right now as we speak, is the famous Interlisp system out of Xerox PARC. It's now called the MICO project, and for various historical reasons, you could look at Xerox Lisp and then look at their Common Lisp implementation, help them out also because it'll be great to have a modern Interlisp itself. I might cover it at some point, but that actually ends up being able to potentially have these kinds of like risky sort of things, just because at the time when Lisp was getting kind of fresh and innovated, they actually ended up uh, trying some of the stuff out, and then that's where they made their mistakes and ended up adding those kinds of adjustments to the standard. Okay, so this is some one reason why you want to write again um, a macro for this, because then instead you could just go in the macro when they're profiling. You could go and check to see when you recall the macro, oh, have you redefined this? And then it can actually go in and, you know, um, anytime it ends up getting called, we can end up, making sure that the profile macro adjusts the calls to be able to actually go and profile them every time. Okay. And that's basically in the macro generation, it calling profile one when it needs to go and see if a function has been changed. Now, naturally, the one that we will be seeing in a minute here, the macro that we'll be seeing in a minute, as far as I know, does not handle that particular situation, if I understood the code correctly. But I thought I'd at least mention that too as well. Um, there are some additional stuff that we will see when we end up I end up writing the code. I'm gonna just copy this guy straight from the book just to make things a little easier for us. Um, Let me see if I could copy this over, and I'm gonna reference this. Okay, shift. Okay, let's see if I can get this in. Perfect. Nice. And I just noticed that there's some messed up stuff here. Just go ahead and say this is on profile, and there's still a couple of things that's missing here. mainly the set difference call that this guy is up implementing, and go here, make this nil. I may also be looking at one thing. Nope, I'm good. Okay. Otherwise, go ahead and do this at difference. And let's see if I do that. Okay. And make that unprofile. Okay. And I'm just going to call this my profile because I don't want our own, I'll just say M profile here just so that it doesn't get confused. Oh, sorry. Get this here. Oh, wait. 3. Okay. That's code. This is good. 2 style warnings. Names. Oh, apologies. Here. This should be a back quote here. And back quote. Let's see what happens there. Compiled function name. So that should be a back quote, comma. 2 style warnings. Let me see what's something wrong here. Yeah, this might be easier if we do. No, that. Better. There we go. We lost it. Okay. And let's also fix the thing here. So what happened is because I'm copying some of this examples from PDF, the formatting in the PDF is actually incorrect when it comes to the macros. So I'm just having to go and retroactively um, correct some of this stuff when I move it over. So just bear with me. I think I got most of it in. Okay, let's go ahead and update this guy, and let's see if that compiles. Okay, one read error warning. What is that? Read error, comma, not inside of a back quote. Okay, my apologies. Wait, not this one. This is in. Okay, did I mess that up? That was, let's see, maybe do I need to make this that? There we go. Almost there. And set difference. This one I have to go and check just double quickly, which is all right. So this guy needs to be, I think, a back quote that fixes this issue. So let's go in here. Okay. Now, both of these aren't, necessarily problematic. Uh, I mean, this is going to still, in some cases, might exhibit some issues. Actually, hold on one second before I begin. I know def var allows you to have that. I just prefer def parameter when we're going to provide initial value. Def var doesn't necessarily allow you to provide an initial value, but def parameter always requires you to provide one. Okay, so the way we are currently looking at on keeping track of functions that we previously profiled is we are updating in the map car the set of profiled functions with this global profile functions guy, and it just returns a list of the profile functions. So if we end up, for example, um, because just for completeness sake, just to remind ourselves, we went ahead and taken out, if I'm not mistaken, we've unprofiled both of these. Okay, so we're good. Let's go ahead and profile them again. Okay, and we're going to create, and again, we need to quote each one that we're going to be profiling. Test 2. Let's do that. And what is it complaining about? It is saying test sum is not a symbol. Oh, it's already okay, because it's quoting it underneath. So hold on one second. I don't need to quote these guys. I wasn't sure. This do I need to do what? Value test 2 is not when binding symbol restarts. Hold on, let me go look at the code because I'm messing up something here. Okay, so we're gonna have to go and look at the macro expansion of this guy and see what happens. Not here. Although we may have to do that at some point. M profile test sum 2. Okay, so we did set union profile functions. Okay, and when profile function 1 gets this guy, it's getting, let me see something. What is this guy getting here? This guy should be getting the, okay, so it should be getting the quoted function, but it looks like it's not. Hold on one second. Not a big deal. We could just M profile. Okay, so let me try this one more time because this should be okay. So we got a symbol function quote test sum. Oh, sorry. This one, it's getting it from this here, and you're getting the quote test sum. Function name is test sum. Interesting. It says that it's not a symbol, but it is getting is not a type symbol when binding symbol. The reason why this is happening is because, hold on. I'm wondering if it's because we're accidentally calling quote or something. Am I using quote here at all? No, I'm not. Okay. Let me just try something here. Profile one, quote, test sum. Okay, that worked. And profile one. Okay. Let's see here. I'll just try this one more thing, and then this might be something we're gonna have to debug in a minute or two. Map car profile. Okay, so I'm gonna just try this without um, the macro. Map car profile one. Test sum and test sum 2. Okay, so one of my quotes is off. Okay. Is it because of that quote comma? Okay, so just to give you guys an update, an explanation here. Quote comma is a typical pattern that you will see when you're trying to essentially return or generate as part of a macro a list of functions that need to be passed over. So in this case, what we're doing is we're trying to get the union of this list of function names. But in order to do that without the list being evaluated as an S expression, we have to quote it. So another way of writing this would be literally quote. So to show this, we could do wrap this guy around. Oh, sorry. Did I mess this up? Oh, we actually have it right here. You can see that what we did is what it does is it generate it quotes the actual set of function names that we provided. Now I'm wondering if what is the union of profiled functions and this list? Is that causing the trouble? Okay, I see what's happening. Hold on, set f profiled functions to nil. That's for starters. So now profiled functions is reset. Now let's run this guy. All right. Okay, so this should be now correct, but we will see what happens. Okay, let's see. M profile test name test sum, sorry, test sum and test sum 2. Okay. All right. So the reason why this happened is because originally I was trying to profile the quote. I was trying to quote the two symbols earlier, but I didn't realize that I had to reset the symbols. Um, Now, once we've done that, we can actually go ahead and run, let's say, do times x10 declare ignore x. Actually, you know what? I'm not going to ignore. I'm just going to do this. Test sum 2 x. Okay. And let's make this a little interesting by calling this 100 times. Okay, so now let's run our profile report on test sum 2. We see that we ran 200 and 20,200 here. We could also run now unprofile here, or munprofile test sum 2. And what is this complaining about? Oh, I misspelled something. Sorry. Ah, okay. And what did it say? Variable if is unbound. Okay, so again, there's a quote problem here. Um, let me see something here. Is this because, oh, wait. I'm going to say variable list is unbound. And where is it getting the if here? It's more than likely, okay. So I have to do the other one. For, I have to use an actual back quote here. Okay, and let's see if that works. And what is it complaining about now? F names is unbound. Where is F names being created? Okay, let's do a quick test here. This is why we have the ability to, let's do macro expand. What is it doing? Okay, if F names, then quote F names. Otherwise, quote profiled functions. Okay. Oh, wait a second. I I see. It is not actually doing the right thing here. So what's happening is the, I wish I could do this side by side, but we'll see if I could do there's a side-by-side thing. I think it was like meta dot or no, it's sly macro expand one. Yeah. All right. So here, let's just show you what's happening is the following. It's it generated the following code, but didn't actually get to bind um, the function names here. Okay, as you can see. Okay, but it checks if it's null, go ahead and return nil. Otherwise, go ahead and do this macro expansion, which is doing the correct thing. So what we need to do is, I believe the fix is if fnames, go ahead and do that. Otherwise, because it's already in a back quote, and then this should work. Okay. Okay. So here, let's quit this. Okay. And let's try this again. Okay. Sly macro expand one. Boom. Okay, so that fixes it. We just had to unquote it. We didn't need the nested quote at all. So let's go ahead and fix that. And if we call this, okay, we have another bug, but what is it? If fnames is unbound, where is it getting the okay, I see. I see. In the macro expansion, I'm going to also have to quote this guy. Let's just do this. If, let's do the same thing that we did in the case of okay, there's one more about comma not inside of a back quote. Let's do that. No, that's not going to help. Do oh, got it. Okay, do that, and we could do multiple ways of skinning a cat. So we do cpwr null, and we're just gonna directly inject this sucker into our code. This should work. All right, let's see what this says. If nil, otherwise, okay, so there is a problem, one more problem with this generated code, and that is we are not matching this and the other one, okay, even though they are in the same top level quote, as you can see here. So let's go back to doing this. Actually, let's do that. Okay. Let's see what happens here. If unproud null. Okay. Unquoted that entire section. That is not what we want to do. go back to that section here. So the issue here is in unprofile there is I copied in something incorrectly. It looks like I may need to do. Okay, let me see if I can do it this way. Um, if this should allow us to do f names, and let's do that. Um, okay, maybe I don't need this. Let me see in this case what happens. Because that is the list of names, and we're trying to generate the code with the list of names. Okay, that works. So now let's see what happens if I don't provide anything. What does it generate? It generates profile. Okay, this this does exactly. I don't know what's going on with the comma generated stuff, but this is kind of working the way I expected to. So I'm just going to go ahead and keep this way, and I'll check it in. But those of you who are following the book does have another layer of unquoting that doesn't seem to work as expected. Um, Now, naturally, I might be making a mistake here, folks who are reading along, saying, okay, I'm missing this quote and that quote. Try it yourselves and write in the comments. But um, I'm letting you know ahead of time based on what I've seen. Um, there, it looks like that the issue here is because of the fact that we are quoting a little too unquoting a little too much here. So once we have this, again, we just saw our profile report just to show you again here. Now we can actually go and unprofile everything. What? Test sum 2 is unbound. Ooh, okay. Why is that the case? Hold on. I may have messed something up here accidentally. Go back to the profile. Oh, it's not quoted. Damn it. Okay, hold on. Simple solution. Quote. Okay. Instead of using. Oh, dang it. Okay, and we're back to that. Okay. I need to debug this for a little bit just to figure out why this macro isn't doing what I expected to. And it looks like we're over time. We're gonna finish this profile next week, and then we'll get into indexing. Again, sorry I started late, my fellow Lispers. Um, if are there any questions as to some of the stuff that we covered here, whether macro expansion or not? Let me know. Post it in the comments, and I will address them next week. We'll finish off chapter 9 next week with the indexing conversation. I appreciate all you taking the time to join us tonight, and I hope you all have a lovely rest of your evening. And good night. See ya. Bye.